Now? All right. Good morning, everyone. This is Block 2. The objective, 1 Alpha, is to identify basic facts about the capabilities and limitations of a high frequency transceiver. You will have a block test on day 5. The minimum score is a 73%. So that means you can miss a total of 4 questions. I want you to shoot for less than 3 because if you miss more than 3, then we have to do counseling and paperwork. So s- try to strive for less than 3. So, how does this apply to you? Well, as an RF transmission systems technician, you need to know the general capabilities and limitations of the radio. Why do you guys think that you need to know what your radio is capable of doing?
So that you can use it to its most effectiveness.
Absolutely. You guys want to be able to use your radio to its max potential. You need to know its limitations so that if your commander comes and he's like, "Hey, I want to do this," you can say, "Well, I'm sorry, we can't do that with this," or "You got it, sir, we got that," or "Sir or ma'am, we can do this."
Like when they ask for
So,
scanning and then you don't purposely give them all the channels they wanted.
yeah, you need to know your stuff so that you can
Limit their capabilities.
limit, mm, I would say guide
Yeah, sorry, guide.
your leadership in the direction that they need to be. Before I go further, I do want to say this is two-way conversation, so if you guys don't understand anything or
Speak
understand
up.
something, speak up. Please let us know. I've got no problem going back over a topic. And if you do answer questions as we go, it will move much quicker.
Yes, it will.
Okay, so the HF characteristics, or radio wave characteristics, are classified and characterized as amplitude, frequency, and wavelength. Did everyone do their reading and know what these are?
Yes, sir.
Sir?
Okay,
Yes,
what is
sir.
what is amplitude?
Magnitude of change in height of the radio wave.
It's almost like you read it word for word. That is perfect. It is absolutely the magnitude of change in height of the radio wave. So McCusker, can you go show the height, sir? Boom, look at that. So there's your amplitude. Up next, we've got frequency. What is frequency?
Frequency is the number of cycles are completed on a periodic quantity in units of time.
Perfect. And wavelength.
The distance between successive crests of a wave.
Perfect. Okay, so if you look at the video, let's say that second crest, the top, so it is from crest to crest. So from point A to point B on successive waves. Frequency and wavelength have an inverse relationship. What do you guys think that means?
That means if
That in.
one is higher and the other is lower.
Absolutely. If one goes up, the other goes down. So if this were a higher frequency that we were looking at on the screen, what would happen to the distance between the crest
I'm shorter.
and we'll call it the mound? What would happen with it?
It would become smaller. Or no, it'd become longer.
Absolutely. So higher frequency is going to be taller and shorter space between the crest. Perfect. There's those definitions that you guys read from the book. Well done. So radio propagation is the behavior of radio waves when they are transmitted from one point to another. So it is just how the signal travels. Does that make sense to everyone?
Yes,
Yes.
sir.
Perfect. HF skywave propagation utilizes the ionosphere, that is the uppermost part of the atmosphere, to make beyond line of sight communication possible. What does beyond line of sight communication mean to you all?
Far distances.
Far distances,
What you
something
mean far
can't.
distances? I'll
Something
give him a
where
shovel.
I can't like directly see you or communicate to you vocally, so I have to
Like a
use
cup
this
and a string?
technology.
Like, can we stretch a cup and a string 500 feet and see if it works?
No.
What?
If there were some repeaters, perhaps.
Yeah, we
but
could. Man. Yeah, you just gotta get like your little brother in between there. He's the repeater. Alright, cool. I like it.
Let's see what's up next.
Did you explain what
Okay.
happens during the day and stuff? That's what goes into the next couple slides here.
Got it. So
So-
when you guys, oh, you want to go back one?
Yeah.
All right. So when you guys look at this picture, how many layers do you see?
4.
So it looks like 4, but there's actually 3. There's the D, E, and the F. The F layer is broken up into 2, depending on the time of day. So an important thing for you guys to remember is the higher the sun, the higher the frequency required. So if it is noon, you're going to want to use like a higher frequency so that you can get through these ionized layers. If the sun was going down, you're looking at 8 o'clock, 9 o'clock, starting to get dark, then you need to use a lower frequency.
I like
Does that
it.
make sense? You like it?
I
Yes,
like
sir.
it.
And explains that a little bit better on the next slide. So all of the layers change according to how much sunlight is going through them. The D layer attenuates lower HF frequencies during the day, so it is more ionized. And higher frequencies do not function as well at night.
What does that mean? What is the HF frequency range?
And our HF frequency range, is that in our reading?
No.
Oh, okay. So good note to remember is the HF frequency range, and that is going to be 3 megahertz to 30 megahertz. So looking at what we just talked about, it is 1:11 in the afternoon or 13:11. What frequency in the HF range do you think you might want to use?
You said the highest was 300 megahertz, right?
3 to 30
Oh,
megahertz.
30. Yeah, you want to use like 29 maybe?
29, I like it. And why is that?
Because the sun would be near its highest point, but not quite.
Yeah, so the sun's up. So when the sun's out, guns out, right? So you want to use a stronger frequency so that you can be able to uh, effectively use the ionosphere for your beyond the line of sight communication. Am I getting the sad face? Did I say
No,
something
you're good.
wrong?
Why did you say sun's out, guns out?
My brain went dumb for a moment.
You're good.
And
It's okay. It helps us remember. It's
That was
this is
great.
beautiful.
I'm never gonna forget that. And it's recorded for everyone forever.
whew, YouTube's going to love it.
Yep.
All right, so up next, we're going to learn about heterodyning. It's the process of combining 2 or more frequencies, i.e. the RF carrier and the intelligence, across a nonlinear device to produce new frequencies. The outputs are the sum, difference, and original frequencies. And the sum and the difference are called sidebands. The difference is your lower sideband, and your sum is the upper sideband. Let's see, somebody was asking about sidebands in chat earlier, were they not?
That
They
was
did.
me.
Let's see. And did you already knock that
Fuck.
out with them? You don't fully understand what sidebands are.
Nah, it mostly makes sense to me now.
Okay, so we're good to go.
I had some time to talk to him before class started.
Okay, perfect. So just keep in mind the difference is your lower and the sum is your upper.
Yeah.
And I want to reiterate, if you guys do have questions as we are rolling through, please speak up or put something in chat. We don't want to leave anyone behind.
We don't know what you don't know what we don't know.
True. So with the information we were just given, if you use that with a 10 megahertz RF carrier amplitude modulated with a 3 kilohertz intelligence, it will generate two sidebands, the difference and the sum. It's your lower and your upper. Both sidebands contain the same intelligence. What is intelligence?
The information that's carried inside the frequency.
Okay, and what type would that information be? Is it water, liquids, or I guess water and liquid are the same. So is it liquid, solid, voice, data, moon pie? Like, what is
It's
that?
yeah, I would say it's data, or
Okay,
probably voice, images, stuff like that.
so it could be audio or data.
Yes,
So
sir.
intelligence is the audio or data that you are trying to transmit. Does that make sense?
Yes, sir.
Yes, sir.
Perfect. So with the numbers that we have on this slide, the 10 megahertz carrier, you're going to have a plus or minus 3 kilohertz intelligence. That's going to be your upper and your lower sideband. So your lower sideband, when you subtract your 3 kilohertz from 10 megahertz, you have a 9.997 megahertz lower sideband. And if you add 3 kilohertz to your 10 megs, you have 10.003 megahertz, and that is your upper sideband. Both of the sidebands are offset from the same value from the carrier. Okay, any questions about those numbers?
Negative.
No, sir.
All right. So we're going to talk about the composite signal. It is the amplitude of the RF changes. The RF carrier changes to match the instantaneous amplitude changes of the modulating signal. The RF carrier has a representation of the audio superimposed into it. So what does that mean to you all? Sergeant McCusker, what does that mean to you, sir?
This is the part where you guys can talk.
I
I think a composite signal is like a multiplexer or a bus signal. These can be thought of as a collection of other component signals.
Sir, we're trying to stay at a 3 level.
Oh, my bad. It's when you ride the top of the wave with your intelligence, bro.
It's when you're riding the wave with your
You're
intelligence, bro.
superimposing it.
I'll roll with it and just placed over. Do you guys see that in the photo?
I have a
Yes,
different
sir.
photo for y'all too if you want to look at this one.
And that being in the Discord,
Oh,
in the
right.
chat.
I think they can all see that. Not sure though.
Yeah.
Okay, I'll go to the next slide for you.
Yeah, so our carrier and our audio go into the mixer, and just like he said, the audio arrives at carrier wave bro.
Yep.
And gives you your modulated carrier wave. Here's a picture I don't absolutely love, but that's what Sergeant McCusker put inside the Discord, and it does show it a little bit better than what they have here.
Yeah, they just have everything a little too scrunched together here.
Yeah, it's a bit wonky. So the carrier has 2/3 of the power. How much power do the sidebands have?
1/3.
Okay, 1/3.
Nope.
So how
Well,
much?
they'd each have 1/6.
There we go.
What? Yeah. Well done, guys. I was about to try to make you do math, but sorry, McCusker just dropped it.
Methamphetamine.
Yep. Okay. Do you guys understand what that number's 1/3 on each side comes from?
Science.
All right. So the carrier is transmitted even when no modulating signal is present. This is on amplitude modulation. So when we get a little bit further in, don't be confused about amplitude modulation and single sideband, but we'll get there. So in AM, the carrier is transmitted even when no modulating signal is present. both of the lower and upper sidebands are transmitted, even though they contain the same intelligence.
What you mean they got the same intelligence on Gaston?
Well, if we go back, I think 4 slides, there's a, well, that's forward. Not you, me. Slide 14. So this is where it's showing that your carrier and your sidebands having the 3 kilohertz spacing. That's going to give you your sidebands, and they carry the same value, the same intelligence. So whatever data that you were trying to transmit, you're going to find on the upper sideband and on that lower sideband.
Ah,
Did that answer your question, sir?
it did.
Okay, perfect. Okay. Let's see. So this is a picture to show you that we've got a total of 2/3 power inside our carrier. And you see the 1/6 power for our upper and our lower sideband. Noise occupies 3 kilohertz, or sorry, 0.3 kilohertz of bandwidth in each sideband. That's that little gray dotty spot right beside the carrier. And this takes up a total of 6 kilohertz bandwidth because you've got your 3 on each side plus your carrier.
What does CXR stand for?
Carrier.
Ah,
So the little red line in the middle is our carrier.
very cool. Why does it say 6 kilohertz of total bandwidth?
So it says 6 kilohertz because you have 3 kilohertz on either side of your carrier, which are your sidebands, and we actually filter out 0.3 kilohertz, which is the noise.
Nailed it. Very good.
Anybody know what noise is?
The static you hear, sir.
Static, spurious, unwanted garbage that we don't want in our signal. Or, yeah, I'm gonna leave
Kind
it
of
at
like
that.
me talking when I don't have my medication. Yeah.
Is the filtered noise, how would you say it? Like, is it the same? So it just is it 10%
It's
of the
filtering
total?
out. I wouldn't say 10%, but it is filtering out 0.6 kilohertz
Oh,
of the
but I was
total.
just wondering, since we're using 3 kilohertz of intelligence and the
Mhm.
filtered part is 0.3, does that mean that that's my question. Is it relative to the intelligence?
That's a good question. I don't exactly know the answer to your question, so I'm gonna
Oh
have
yeah,
to look
because I was
that
just
up.
wondering because
I have
that's the
never
only
been
way it
asked
makes
that
sense
before.
by 0.3.
Yeah, I've never been asked that before because you can change this number when you guys are programming the radios, and you'll see that tomorrow when y'all are in there programming the radios. You can actually change the bandwidth size almost when you're transmitting and receiving on the radios themselves tomorrow. So that's a good question. Because I don't. Are you asking like, is it always going to be 0.3?
Yeah, if it's always going to be 0.3 or if
I
it's
believe so.
relevant to the actual
No, I believe
intelligence.
it's always going to be 0.3.
Oh, okay, yes. Because since 0.3 and we're using 3 kilohertz, I just thought that it
Mhm.
was 10% of our intelligence.
Yeah, no, I wouldn't say it that way. But I like that. I like where you're thinking. All right, cool.
All right, here's an AM signal on a spectrum analyzer. So if you're looking at the photo, the wave all the way to the left is going to be our lower sideband. The middle one is the tall one, that is our carrier, and to the right is our upper sideband. All right, so to go over what we've talked about so far, we've talked about how intelligence creates sidebands, and it consists of the carrier, the upper sideband, and the lower sideband. Both sidebands have the exact same intelligence. Sidebands start from the center frequency, the carrier does not change, and it contains no intelligence. It will transmit even when it's not modulated, and it requires a bandwidth equal to 2 times the highest modulating frequency. So that's AM. Any questions over AM? All right.
No,
I
sir.
love it when they say nothing. It's just great.
Yeah. Just gonna press right on through because
Yep.
that means they know everything.
That's what it means.
All right, so now we're going to talk about single sideband. So it's a variant of AM that uses transmitter power and bandwidth more efficiently by suppressing the carrier and one of the sidebands. So when it says upper sideband or lower sideband, that means you can suppress the upper or the lower. It will not always be upper, and it will not always be lower. So
You
it's
mean
just
eliminate,
whatever.
right?
Yeah. Yep. You're right.
Sir,
Sir, what you got?
is the lower sideband on an AM signal always on the left, correct?
Correct.
Thank you.
Okay. So the primary usage for single sideband is beyond line of sight communication.
Sir,
What you got?
for the single sideband, like how do we determine like that it's a single sideband, or do we make it a single sideband? How does that work?
You will make it a single sideband when you are programming the radio, and you will all see that tomorrow.
Yes, sir.
That was terrible, but there's your carrier. There's your USB.
So in his depiction, you can see that the carrier has been suppressed.
Yep.
And the upper sideband is the big boy because it is receiving all of the power, or most. We'll get to that in a moment when we talk about our pros of using it. Another
Lots of
fun thing
pros.
about single sideband. What was that, Sergeant
I said
McCusker?
there's lots of pros.
There are. I think it's advantages is how I have it in the slide.
I like saying advantages.
I couldn't think of it at that time.
That's okay.
But so a characteristic of single sideband is no signal in, no signal out. So if the modulation doesn't occur, you're not going to get anything out of the radio, which is different from AM because AM does what?
It'll
It
signal and modulates.
Modulates, yeah. Even if there is no intelligence going in, it's still going to be transmitting or modulating, yeah.
So what do you mean? If I don't say anything, nothing happens?
Are you pushing the push to talk button in this
Nah,
scenario?
I forgot.
Okay. Yeah, so if you're not putting intelligence in, then its modulation doesn't occur and you're not going to be transmitting. And here is another depiction of the picture Sergeant McCusker drew on the last slide. So you can see that the carrier is suppressed. If you look all the way to the left where it says sideband removed, that is where our lower sideband would be, but it has been completely removed, carrier suppressed, and everything in the power is focused on one sideband, which in this case is our upper sideband. That makes sense to everyone?
Yes, sir.
Sir.
Yes, sir.
Super. So there are just a plethora of. I can't
Yeah,
even
there's
talk
probably
today.
even more not listed here, honestly.
Yeah. So a lot of advantages. One being spectrum conversation, power
Ooh,
efficiency. Yeah, spectrum conversation is a big thing, especially in this HF range because it is not exactly a huge band.
sorry, Gaston, you keep saying conversation
Did I?
twice.
Dude, I've listened to you do this too many times then.
Yeah, so he's saying that because I normally say spectral conversations. That's talking to ghosts. Because I had a student misread this one time, and then I just clung onto it.
Sir, what exactly is spectrum
Oh
conversation?
man, I think it's so
Conservation.
great that you asked that question. Sorry, Gaston, why don't you enlighten him?
All right, spectrum conservation, not conversations, because we're not talking to ghost, refers to decreasing bandwidth of each channel in a radio system to allow for more channels in the overall radio. The total HF spectrum is smaller, and therefore channel spacing needs to be smaller.
Doing
So
more
if
with
you're
less.
doing more with less. So if you remember our HF or our AM from earlier, it was taking up that full 6 kilohertz spacing. On this, you don't need all of that because you are killing one sideband and you're suppressing your carrier. he's going to get to the picture. Yeah, so that's AM. So you see how it's taking the full 6 kilohertz. But in the upper sideband, we're going to just eliminate everything to the left of his circle minus some of the carrier, and it is only going to be suppressed, so it's not going to take up space. Does that make sense?
Yes, sir.
It means that we can
Yes.
transmit on this side and also transmit on this side, and they can be completely different things. And they can also be the same frequency.
So it's like if there's just white noise coming out, then you would be like, oh, I don't want this, and then stop transmitting.
So if you want, I can show you guys something real quick. I'll show you this software I've got, because it kind of gives you a better depiction of what he's talking about. Like, it'll show a physical image. So let me show them that. You know what I'm talking about, Sergeant Gaston? The CPA.
The thing in your
Yeah, CPA.
Yeah.
Because it draws the little bandwidth thing on the side. Like it draws out that the graph, the amplitude and frequency graph. Let me do that for you real quick. All right, here we go.
Can upper and lower sidebands be used interchangeably, or are there
We're gonna
instances
show
where only
you.
the other would need to be used?
They can be completely different.
Okay.
They're not carrying the same intelligence in this instance, if that makes sense. All right, can y'all see this?
Yes, sir.
All right, this is CPA. You're going to learn about this more tomorrow when we do our lecture tomorrow. But what he's talking about right now, you guys see that USB right there? I can change it to LSP.
Yes.
And look at that. See, it switches sides. And they're the same frequency, but you'll notice what he's talking about there. So if we look at the lower sideband one, and they're the exact same frequency, it takes up 6.7817, 6.7847, 6.7853, and 6.7883. So that's why you're able to have them on the same frequency, because they're not truly on the same frequency. Does that make sense?
Yes.
And you guys can see that with the little image down here.
Yes, sir.
All right, cool. We'll get more into this program tomorrow. I don't want to talk too much about that program right now. Get your thing back up for you. All right, there you go. Sorry, Gaston.
Perfect timing. All right, so here's a picture. Probably isn't as good as what he showed you guys on the CPA. But if you look on the left, that is our traditional AM, taking up the full 6 kilohertz bandwidth, and the upper sideband on the right, which can be interchanged with lower sideband. Doesn't matter, it's not always one, not always the other. But it is less than half of the bandwidth of AM. So you can see that it is from 10.003, 0003 megahertz to 10.003 megahertz, which is a total bandwidth of 2.7 kilohertz.
Yeah, and that has to do with kind of what we were just talking about there.
So, main idea here is it takes up less space. Everybody good with that?
Yes, sir. So you're essentially
Yes, sir.
you're covering less space, like frequency wise, and you're also
Yes.
just taking up less bandwidth. So it's like
Yes.
if you know exactly what frequency you need to be on, you can.
Pinpoint it better.
Yes, sir.
Yep. Look at that guy. Nailed
You
it.
can have, yeah, just allows you more room for the spectrum manager to share.
And it's great when you guys think about it too, like he's saying, because the HF range only extends from 3 megahertz to 30 megahertz. So you just basically made a ton of more space available to you.
So is that like go all the way down to like pico or is it picohertz?
What are you talking about? With this radio? No.
What is the actual range?
In terms of
Like
frequency?
so for spectrum conservation, which you showed us. You showed
So
us
for
that it
this
was like
radio, we go from
point-
1.6 megahertz to 29.9999 megahertz.
so to 4 decimal places, I guess. is what
Yeah.
I'm asking.
Yes.
Okay.
Yeah, but the radio, I think you can only adjust 3, I want to say. It's been a minute since I've been in front of the radio, but I think you can only adjust the last 3 on it. But you guys can play with it tomorrow when you get in front of it.
Okay, any other questions about that portion or that advantage?
I like these questions they're asking.
Oh, I've been over here waiting for you to change the slide, but I didn't have the live stream pulled up. All
Yep,
right.
you didn't.
So the another advantage is its power efficiency. So available power is concentrated in the one sideband utilized, and power output is only developed when the carrier is modulated, which is the voice or data. And what is another fun term for voice or data?
Information.
Intelligence, absolutely.
Yep.
And let's see. Yeah, that's all I got. Anybody got questions? Pressing
sir.
on. So because of the, let's see, the effective gain in transmit. So the HF radio inherently has more gain efficiency when compared to AM. It's because a single sideband transmitter can concentrate almost all of its available power into a single sideband, making this transmitter more efficient. A 100 watt AM transmitter transmit equals 25 watt single sideband transmit. And then they go through some math. So 100 watts divided by 2 equals 50, and then 50 divided by 2 equals
Yeah,
5.
and I don't know why they didn't just do 1/4 of 100 there, in case anybody's asking.
Yeah, I was gonna ask that.
Yeah, I don't know. I don't know why they didn't do it that way.
I guess because 100 between 2 because of the 2 sidebands, and then
Yeah, I guess.
Yeah. So in the right picture, you can see that the carrier has been suppressed and you have a total of 6 dB gain in transmit. There's also an effective gain in receive. Since there is since there is noise present throughout the frequency spectrum, approximately half of the noise is received with this bandwidth reduction. This gives single sideband receiver a 3 dB gain. So without all of the extra noise, you're gonna get 3 dB gain on the receive side. Questions, comments, concerns?
So having more power would allow you to make the frequency louder.
No. Having more power would allow the frequency to go further.
Oh, okay, that makes sense.
Yeah. So remember, gain is dB. It's just a measurement of like the power or the signal strength, right? It doesn't necessarily mean you can adjust the volume with it. In fact, if you're adding more gain, you might be getting more noise too with that.
Okay, that makes sense.
So that like 0.3 kilohertz might expand a little more if you put something like a power amp on there.
All right, got it.
It's like most electronic systems. More
I
power is
was
not
wondering.
necessarily always a good thing.
I was wondering. For the gain, it says it gives it 2 sets of 3, so it gives it +6 gain overall. Is that consistent, like overall, for every type of single sideband? It's only +6 gain no matter what.
That's this system specifically.
Okay.
It's not going to always be that way. That's just for our radio.
All right.
I mean, every radio is going to be different when you look at it. This is teaching you
So
how to do the total effective gain.
okay, so like the explicit number will be like put in our TOs that we get
Yep.
for said system.
Yep. It sure
Okay.
will. Yeah, if you never know where something is as a piece of equipment, or it's your first time approaching a piece of equipment, especially for those of you younger guys who are going to your bases, like the best thing you can do for yourself is to go pick up a TO and like read through it. It's not super exciting, I understand. There's no pictures or
Yeah.
anything, but
They
there's some
do.
pictures, I guess, but not interesting ones.
Yeah. Yeah, they're a bore.
Yeah.
All right, so we talked about the effective gain in transmit and receive. So the total effective gain is simply adding the effective gain from transmit and receive. The effective gain of 6 dB in transmit plus the 3 dB in receive gives you a total overall system gain of 9 dBs.
Nice.
Everybody understands that math?
Can I
Yes,
ever have them both at the same time, Sergeant Gaston?
Can you ever have an effective 6 dB while transmitting and then receive it at 3 dB effective gain? You
Uh-huh.
cannot.
Why?
No, sir. Because if you were transmitting, you were not going to be receiving with this radio.
Oh,
Yeah,
facts.
yeah. So this is not a full duplex system. So when you push to talk, you're not going to be receiving to get that 3 dB gain.
So it's only going to be either 6 or 3.
Yes, that's
At
correct.
a single point in time,
That's
yes.
correct. Because if you're transmitting, the other radio is receiving. You can't transmit over top of each other. This radio is half duplex.
So that makes it, is that link 11A? It's half duplex? Is that what
What?
that is? The
Oh,
we
you're
learned about
bringing
like,
in some block one nonsense. Yeah, no, we're not really talking about that.
Can you go back a slide, please?
We're not really talking
Thank
about that tattle stuff. That stuff you learned about in was it tactile application digital information link or something?
yes, sir.
Yeah. Yeah, we're not talking about that. I know what you're talking about. That's like
yes, sir.
UHF and SATCOM type stuff.
So that doesn't apply to this
No,
necessarily?
the radios have to have that capability. We don't have that capability with this radio.
So it's just a
Okay.
case by case basis.
Yeah, it's going to be a case by case basis. That's why I said like reading your TOs and stuff is going to help tremendously. Oh, there you go.
Okay.
There's that word. All right. Somebody asked me to go back a slide though, right?
You could push on if you'd like.
Okay. Did you have a question?
No, I was just bringing it down.
Oh, okay.
Thank you.
All right, so peak envelope power is the transmitter's average power output during one RF cycle. It's a sample at the highest crest of the modulation envelope. The signal is sampled in predetermined time intervals and measured. A 100-watt single sideband transmitter, when keyed and unmodulated, will have virtually no power out. If no audio is applied, no sideband is developed. Because, why is that?
Because there's no information.
Absolutely. We're talking single sideband here, so no intelligence, then nothing's coming out.
Yep. Here's what your signal will look like.
Flatline, yeah.
Yep. It's not going to do anything. If you guys think about it, and when you look at the signals when you're watching for the radio later in the block, do they still do the radio portion for the spectrum analyzer?
Talking about block 1.
No, this block.
Did they
That's
still
part of our
do?
lab for the PMI.
Oh yeah. They still use the spectrum analyzer.
Should listen to the radio.
Sound, look and listen.
Yeah, the look and listen function. Yeah.
Yeah,
So if
yeah.
you guys go in there when you do that and you like watch a song or you like watch somebody talking on there, it's gonna like move. You'll see it like going up and down.
Sweet.
Yeah. And then like when they're changing songs or when there's nothing on there, you'll notice it doesn't really change. That's kind of a good application of seeing that in person.
All right. Any other questions on that? Or are we good to keep pressing?
Keep
Yes,
going,
sir.
sir.
Perfect. So another advantage is it has better signal to noise ratio. So bandwidth is less than half of AM, and the overall noise is reduced because the other sideband is eliminated. So if you guys remember the photo of single sideband, you have a carrier being suppressed, one sideband completely eliminated, and the one sideband remaining. So therefore, you're going to have less noise.
Awesome.
So to talk about what we just talked about, we discussed the radio wave characteristics, propagation characteristics. We talked about heterodyning, amplitude modulation, and single sideband characteristics. Are my slides different than yours?
No,
Oh,
you're good.
I
You just
scrolled.
did your.
Oh,
You just won ahead of me.
okay.
We're
All
on
right.
CCI next.
All right. So controlled cryptographic item. What does this slide mean to you all?
I don't want to go to jail.
You don't want to go to jail.
That's what it means
That's
to me.
true. It is.
I don't know about that one.
Especially
It
not for
means,
other
like,
people's mistakes.
if we're trying to send intelligence to, say, like somebody in like the combat field, or perhaps like as Technical Sergeant McCusker was with the I believe White House comms,
Mm-hmm. What about it?
you would have to encrypt
We did.
all like communication signals, so that'd be
We
with
did.
the CCI.
Look at that. Way to bring it back to something you learned about today. I like that.
Yeah.
That was good.
It was. That was nice.
That guy pays attention. I like it.
He's a true hero. So CCI, the radio has a capability to encrypt and decrypt radio signals. It will obtain the classification loaded into the equipment. Guidance is somewhat vague, but it's generally understood that this equipment will never be left unattended.
What
So
does that mean?
This goes back to what Sergeant McCusker was saying, is he does not want to go to jail.
No, I do not.
So,
So please lock the door when you leave.
yes. So when we are in the classroom tomorrow, we will not be leaving the door open with nobody in there and this equipment just laying around, because I don't want to go to jail.
He
You guys
doesn't want
don't
to go
want
to
to jail.
jail.
It's just a bad time altogether. Is there anything else I need to hit on? Oh, each radio is $20,000. We have 7 of them.
12.
Question. Oh, well,
There's some in the cabinet.
I wasn't gonna tell them about those in case they decide they're gonna eBay this.
They're not
So
going to eBay it. Then they'll
they got
definitely go to jail.
Yeah, bad time. So they're valuable pieces of equipment. They have capabilities of encrypting and decrypting, so we want to make sure that those
Sergeant
assets
Gaston,
are,
why is this radio CCI? Even if it doesn't
why,
have an encryption on it, why is it considered CCI?
because it has the ability to encrypt and decrypt within it. So there are
Oh, so it's embedded.
it is embedded crypto. What is that? The A3, A5?
A2, A5. You almost had it. You're getting there.
I'm trying.
You're getting there.
Yeah. So there is embedded encryption, which is,
It means it's internal and you guys can't remove it, right? So, like, we can't open this radio, is what he's getting at. In the classroom, we're not allowed to because you have to open it in a secured environment. We couldn't even open it in the maintenance room across the hall from us because it's not what the Air Force deems a secure environment. If we wanted to open this radio, we'd have to have not only the certification from Havers to actually do so, but we'd also have to have a secure environment to do it in.
Is this where you bring up the jailbreaking?
No, that's J6.
J6?
That's
Okay.
tomorrow. Yeah.
All right.
That's tomorrow, but you can tell them about that now, I guess, if you want.
Well, I was just gonna throw in, just kind of like if you jailbroke your iPhone, Apple's not gonna do anything for
they
you
won't
ever
do
again.
anything for you ever again. Yeah.
And it's the same kind of concept here. If we open this up and start jacking around with the
Yeah, there's tamper tape on the inside. They know if you broke it.
Yeah, and then Harris isn't happy and it's just a bad time. So I'll save your jailbreak story for tomorrow.
Yeah, you can save it for tomorrow. That's cool.
So more so to like turn the equipment into like actually use the encryptions or decryptions in the equipment. You have to go inside of it and change the hardware, or is it like software going in to change
it's
like
kind
my
of like
graphics
software.
card?
It's kind of like software going in.
Okay.
Yeah, you just plug in a cable to the front of your
cable.
radio and to your computer, or sorry, your key loading device, and then you load keys through that.
Yeah, and that's section 1 Bravo, and we're gonna get into that when we go over this stuff tomorrow with y'all.
Yes, sir.
We don't want to go over too much today because y'all are probably just going to forget this stuff if we go over all of it in one day.
All right.
Cool.
Does everyone have their TOs?
They better.
Anyone missing materials? This is the time to say I do.
I'm missing
If
some
you do
crayons.
not.
Do you know where they are?
Where is it located?
So this is in the student materials folder. Let me check Discord before I tell you wrong.
Not student materials. It's in the course materials folder, I think, at the top. Check out this sweet snub nose this guy has.
So I got the Aeroflex, HF technical manual, HO. Yeah. I have like 3, I think, and they're in the student material.
Okay, so if you downloaded your student materials inside block 2, I'll walk through it with you. Student materials. So you want to open up for
Commercial
today.
operations manual.
Yes, your commercial operations and your intermediate maintenance manuals, please.
Please.
Oh my God, get off there, computer.
Uh,
Trying to spread it out. It's just
Not working,
anywho.
huh?
Nope. My mouse is starting to give out on me.
It's not good. You need to get one of them new mouses. Mices?
This is
Mice?
this is a
What is the plural?
decently new mouse, but it anywho.
Yeah, go ahead.
So we're gonna just keep pressing.
Yeah, just keep pressing.
So if you turn to page 1-3, that's PDF page 26 in your immediate maintenance manual, page 1-4, it's going to tell you your radio specifics. It's going to give you a ton of information. And if I were in class, I would be jumping up and down telling you how important table 1-1 in your PRIC 150 commercial manual is.
Yep, he would.
And you guys, is everyone familiar with the idiom beating a dead horse?
Yeah.
Yes,
You
sir.
use a dead horse to beat a stick.
Yep, you beat a stick with a dead horse. And I'm
Yep.
going to beat that poor stick all week long into your heads that table 1-1 is pretty cool.
It's pretty cool.
It is. It's top notch. It can get into all the VIP rooms.
How much water can I put my thing in?
That's a good question. Does anyone know how much water Sergeant McCusker can put his thing in?
None.
Are you
Incorrect.
sure?
And by thing, we're talking about the radio.
Yes.
Yes, sir.
Had to be specific there.
I didn't want to have to.
Yep.
Yeah.
Yep. Just leave it at that.
So
0.9
Meters.
milliliters of water.
Meters.
Meters of water.
Yeah, meters.
Oh man.
yes, you can immerse it to 35.4 inches of water. Do you want to just sit there and leave it in 35.4 inches of water?
Should we memorize all this?
No. Why would you not?
Why would you do that?
Is there something that oh, you know what? I didn't say this at the start, so this is on me. When you guys test on Friday, you will have access to 3 TOs, being your commercial manual, intermediate manual, and your the Aeroflex, the CSM manual. So you will have all of these at your full disposal on the test. So there is no reason to memorize how deep you can put it in water. Immerse. Oh, what is the difference in immersion and I can't think of the other word right now.
Submersion.
The difference between immersion and submersion.
What does a submarine do?
Submarine goes underwater, like completely.
When you immerse something, what do you do with it?
Going into it.
Yeah. When you immerse something, you put it around it, right?
Briefly. You briefly put it in that thing.
So it's like a dip.
Yep.
That's perfect. Are you looking on Google? Because that's what I did to make sure my definitions are good. And that's The Google definition is to dip in a liquid.
There are a lot of
Servo
you
has a
Google.
big brain.
Yeah, y'all are allowed to use Google.
Yeah,
I
Do it.
didn't.
not on the test, but
Not on the test, but yeah, do it right now.
right here.
If you don't
Yeah.
understand something, look it up. That's what I'm
Okay.
doing.
So using table 1-1, what is the frequency range of this radio, being the AN/PRC 150 Charlie?
The frequency range is 1.6 megahertz to 59.9999 megahertz
Absolutely.
in 100 hertz steps.
And what is the HF range?
Ooh.
This might not be in the table. This might be
Also
something
not
you
on the
just
page I'm
want
looking
to.
at.
This might be something we talked about, like slide number 5. You just want to remember this one.
Is it? Oh yeah,
Isn't
it's
it
the
3 to 30?
1.6. It's 1.6 to 29.
That is the HF range for this radio. Is 1.6 megahertz to 29.99999.
Is it 3 to 30 megahertz?
It is 3 to 30 megahertz. That is our HF range, but not of this specific radio. Keep that separated in your mind, but it's important to know your HF range.
That might have been my
So
fault. I
that's
was
just
drawing
a-
it on the screen.
Yeah, I saw that.
That's a general
Troll 'em.
range for all radios?
No, that is the factual range for this radio, man. So it goes a little bit below the HF range. That's what he's trying to tell you guys. Like, it goes a little bit below the HF range, and it actually dips a little bit into the VHF range itself, because the HF range, like he's trying to tell you, is only 3 to 30 megahertz. So we're going to be a little bit below that, using some VF, or LF, sorry, which is low frequency, and we're going to use a little bit of the VHF range as well. Does that make
Got
sense?
it.
No, you're doing great, Sergeant
Yes, sir.
Gaston. You're crushing
Oh,
it,
no,
man.
Oh, thank you. I think you're crushing it with the slides.
Aw,
Yeah, and the students, you guys are all killing it.
they're
I really
killing
like.
it.
I
Thank you, sir.
appreciate all
I
of
like
the.
that they're all talking. That's really nice.
Yes,
It's like somebody
that's
yelled at them or something.
what I was gonna say. Is they are very participative. That word.
Yeah,
They're
you're good.
participating. So, what is this table?
This is 1-1, what we're looking at.
No, that was more of a dead horse moment.
Oh, my bad.
Good job. This
My
is
bad.
table 1-1 in our
Yeah,
commercial manual.
You guys nailed it. Way to go, guys.
And it's going to give you all the capabilities and limitation specifications of the PRIC 150.
Hey, what can you guys tell me happens to the radio? At what point does it shut down when I don't have enough power? Oh, let me get off that page. Let me ask that question again. When does the radio shut down when I don't have enough power applied? How many volts can I operate on still?
Looks like 21.
Okay, what happens when you go below 21?
Just
All right, what happens in the 21 to 23 range?
output is reduced -6 dB.
What does that mean? Since we talked about what dB is already, as it relates to power.
That's like how far the transmission can go.
Yeah, so are we gonna try and send something halfway across the world or at a time of the day when we don't have a lot of battery power in our radio?
Hell no.
Nope.
Good answer. I like it. Cool. All right, Sergeant Gaston, you got this. I
All right,
believe in you,
so
Naruto style.
I'm not familiar with Naruto.
Believe it.
I apologize.
You're good.
Oh dear.
Yeah, sorry. I'm not your
We'll
anime guy.
leave that alone.
Yeah. So, anywho, our radio has several different modes. There is fix, that's single channel. It's got hop, which is frequency hopping. It utilizes automatic link establishment, 3G, and 3G plus, which are both faster, better, newer, greater forms of ALE.
What is ALE? That stuff I have to be 21 or older to drink?
An automatic link establishment.
Oh man, look at that guy.
Perfect. To answer your question, Sergeant McCusker, we will get that in a few slides.
Okay.
Yeah, unless you want to skip ahead and we can go to ALE first.
That's up to you.
Yeah, we'll stick with it. I like seeing the slide that we're on.
That
So
does help.
fix Fix's single channel operations are performed in this mode. Manual channel is 000, and with that channel you can change the frequency. You can change the modulation type, the gain. There's a lot you can change from the manual. So I
What
think
happens if something's broken with the radio? Do you want to go to the fix mode? Eh?
Well done, sir. Well done.
Hey, I'm only saying this because I literally had an airman at my first base I went to. Well, last base I was just at actually say that to me, and I was like, "What?"
Oh man. If your radio's broken, send it to Harris.
Yeah,
Don't
send it to
be
the
wild.
fix mode. Yeah. All
Oh,
right.
so
Sorry, that was a
within
corny instructor radio joke for you guys. I apologize.
so within Fix, you have system presets and normal presets. You can find out how many of these presets in table 1-1 of commercial manual. Just gee whiz information. In Fix, you got single sideband scan. You can refer to your ops manual to get more information on that. And it scans multiple channels that have been programmed. And it's similar to how Citizens Band operates. And it stops scanning when the signal breaks. Let me try that again. Stop scanning when signal breaks the squelch. And it is only in plain text.
Ooh, what's plain text mean?
Well, sir, right now we are talking in plain text. It is clear information.
Oh man, how do I get them encryptions on there?
You get those encryptions with a loading device
Oh,
through
okay.
your accessory port on the radio and a.
Through where?
It's the accessory, yeah? J6?
Yeah, not the J18 Phil?
No, you don't want to use that one. That's like KP duty.
Through a
Don't touch it.
CCA.
You don't want to use J18, the Phil port?
Let
For
me look at
encryption?
I've got to look at my drawing. Did I overspeak?
Yes.
Oh, well, don't listen to that part. Ignore that portion.
Yeah.
I'm not looking at my
So
diagram.
J18, that's okay. So the stuff we're talking about is stuff you guys are going to go over tomorrow. The J18 is the fill port. That's the port you're going to use for encryption, decryption. Well, I shouldn't say decryption, but encryption. That's the port you're going to use for loading keys. It's above the function switch, which is where you actually like turn on the radio. He's talking about J6 and J9, which are accessory ports. J9 is the one you do not touch, so I'm guessing.
Well, I knew that part. I
Yeah,
said KP
you
duty.
got it. You just had to take half of port A18 and you would have been good.
Yeah, that's what I.
There you go. You were just
I
doing
can't
some
believe you
math in
didn't
your
know
head.
that. Yeah, math, numbers.
Yeah, you're good.
So
You can keep
single
going.
sideband, got it. Single sideband scan, that is all channels. That's 000 through 199. It includes the upper sideband, the lower sideband, and FM. And if HF and VHF are scanned together, it requires a wideband antenna that is capable of doing that full spectrum. Because if you're using just an HF antenna, you're going to have some problems with the VHF, and vice versa. Does that make sense to everyone?
Yes, sir.
No, can you go a little more in depth on that?
Yes, he can.
Sure. So if you were trying to use your HF antenna to talk on frequency 59.9999 megahertz, trying to pull something up for us?
Oh, yeah, sorry. Did it show you that? That's funny. Yeah, I'm gonna send him something, but keep going.
Okay. Then you would be the antenna would not be rated for that frequency, so you would have some impedance mismatching, and your transmission could have essentially it would not be as effective as it would if you were using an antenna rated for the frequency that you were trying to use.
So if you're on 59.9998, it's fine.
No, if
you're
you're
not gonna use an
using
HF antenna for that.
so our HF range, if you remember, is 3 to 30 megahertz.
All right.
So if you're using a frequency above that 30 megahertz, then you are now in the VHF range. So your antenna would not be rated appropriately. So if you want to use that full spectrum of the radio, you would want a wideband antenna that can handle it, or an antenna that could handle those frequencies. Does that make better sense?
Yeah, I got it. Thank you.
All right, so slide 43, we're going to talk
Slide
about hop.
43.
That is a form of electronic countermeasures, ECCM.
And if you put an I in front of it, you can get pancakes there.
I'm not tracking that.
IHOP.
Mm.
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 Oh,
Putting
man.
it in front of ICCM, and I'm trying to figure out where is he getting
What?
IHOP.
What?
Yeah,
This
me
man doesn't know
too.
his letters.
Oh my goodness. Sorry. Go ahead.
Can you tell me how you transition into this next part?
You just literally start talking about how ECCM works, and how what like transec is, and the differences between like how it kind of works and what they're going to do, because they're going to get to set this up in block 3. We don't really get to do this in block 2.
Okay, so hopping is a form of electronic countermeasures, part of a transmission security technique, also known as transec. It's where our frequency constantly changes by hopping. You can use this for anti-jamming, so if your opponent does not know which frequency you're on, it's a lot harder for them to jam you. It has special setup and timing requirements. But you guys, as he alluded to, will learn much more about this in block 3, where you're going to set this up into your radio and practice and utilize hopping.
Pretty cool stuff.
It is. What is the drawing?
It's jam. It's a bottle of jam.
Jam. Oh. All right.
Keep going. You're good.
You guys can learn more about hopping in the operations manual, table 1-1. It doesn't function like traditional electronic countermeasures. Still an effective. Is this slide wrong?
No. Well, the spelling's bad, or the grammar, but it's not wrong.
Okay, the grammar hurts me. Still an
You
effective
asked that
in
same question
preventing.
last time.
What was
It's
that?
still an effective means in preventing jamming.
Okay, still an effective means in preventing jamming. So, only hops on pre-programmed channels, so you would have to set this up. Must be synchronized. Only hops within the HF frequencies, which is 2 through 29.999 megahertz. You can find that portion also in table 1-1. So you're not going to be able to hop from 1.6 to 29.9999. You're going to do it from 2 29.999. It's right there in table 1-1. He's lighting that up in Discord for you. And it uses the frequency hopping time of day.
Can you tell them a little bit more about time of day?
I would rather you did, so that I can get more comfortable on it, if I can answer it that way.
Okay. I always look this one up, actually. So I don't want to tell you guys the wrong thing, because I don't specifically teach have quick and time of day and stuff. So here's what I'll give them. But it's a form of like have quick, which is you are specifically doing it for that time of day, which is the net number, the actual time that you're doing it. So like if we were going to set it up for noon, we would set it up for noon and say like this is our specific time that we're going to do this transmission at. And then there's other stuff that gets involved with it too. So like you have to put the net number and input the cryptographic pseudorandom number generator as well. So there's more to it, and that's why they say you guys are going to go over it in, what is it, block 3? Because you actually get to program this still in block 3, which is cool. There's a little bit more about it on the bottom here.
Okay, so you can hell a hopnet.
Yep, you can definitely do that.
That's also in your operations manual. It permits a station in fixed mode to alert other net stations that are in hop mode that a fixed station wishes to communicate. ECCM has programmed channels to monitor the hailing channels. So this would be if all of you were in a hopnet and you're just chit-chatting, having the time of your life, but for some reason I didn't get the memo and I want to talk to you guys. I can hell the hopnet and let you guys know, hey, I'm here and I think it'd be pretty cool if you'd let me in. Make sense?
I like it. Makes sense.
Yes, sir.
Perfect.
Could it be likened to like pinging someone on Discord? I feel like that would be the easiest analogy.
Mm,
Like you're trying to get their attention?
Yeah.
Yeah, it's kind of like that. I mean, a little
There's
different
a
because
little more to
imagine
it.
like they're in a secure mode and you're not.
Right.
That's the difference there though, versus like a
Okay.
ping. Like with a ping, you're both on like an unclassified network.
Okay. Okay, thank you.
Does that make more sense? So remember
It
that too.
does, yeah.
Like he didn't mention that just now, but if you are talking on a hopnet, remember when you go to that hailnet or that hail channel, you're not secure anymore. So don't say anything you shouldn't be saying.
Okay.
They'll get you that way.
Say that one more time.
Yeah. So if you're on a hopnet, you're in an ECCM mode. You're in an electronic countermeasure mode. When you go to that hail net, the one that's outside of your net that someone is trying to talk to you from, you're not secure anymore.
So if someone's requesting access,
They're
into
not going to
your
request access that way. They'll probably just try to get your attention so you can find out where they are so that you can get them physically the frequencies. Don't ever give out frequencies over the radio.
right?
Ever.
Good to know.
Yep.
So when would I be in an unsecured network then?
A lot. I mean, pretty
I
often.
guess. Okay, so this doesn't relate to hop. This is just generally speaking.
Just generally speaking.
Okay, cool.
Good question.
Any more questions on that?
Nah, they're probably all getting hungry, man.
Oh, all right. Well, Burba's typing. Burba, your mic works. What do you
Wow,
got
it's
to say?
already lunch.
I was just typing for thought.
It's because you guys are having so much fun. Time flies when you're sitting in lecture on Discord.
These next few should go
Yeah, they'll
quick.
be pretty quick. We're almost done.
All right. So AOE, that's automatic link establishment. It uses a specialized radio modem to automatically control an HF transceiver to establish the highest quality communication link. AOE alleviates the need for radio operators to manually check frequencies and adjust for changes in the ionosphere, time of day, or interference. It uses link quality analysis, which allows the radio to automatically select the best HF channels based on a scoring system.
Nice.
What were you trying to write out?
I wrote 21 or older only.
Ah. Yeah, not that version.
Ah, not that version. Okay.
So the ALE controller handshakes to confirm the ALE link has been established and communication can begin. When operator initiates a call, the ALE controller checks the LQA memory table from the idle channel with the best quality score for both sides of the communication link. So if you guys look at the blue chart, the vertical far left where it says radio R2, R3, R4, those are radios, and the 4 items on the right are the channels. So looking at this, using ALE, which channel do you think the radio would choose for communication? What has the best scores collectively?
Channel 3, sir.
Channel 3, perfect. Why is that?
Because they're more consistently high instead of being high on like one end, like R2 and R4 are fairly high on channel 1, while R3 is low,
Yeah,
and it's just consistently average.
yeah, the radio wants to be fair to everyone. It
I
wants to give you
like
the
that.
best.
Consistently average.
Perfect. Do you guys have any questions on ALE? All right, so oh, nope, not typing. All right, so you can learn about that in your tech manuals and your operation manual if you want more information. So there's a couple of modes of ALE. There's the 3rd gen, that's 3G. So it has faster linking. You can operate successfully in a lower to signal to noise ratio. And then you've got 3G plus, which does everything from 3G to an ALE, but it also allows the radio to receive and place ALE calls while operating in 3G. So as I said earlier, it's just latest and greatest. So we've got sounding in ALE. We're talking about that still. So sounding is when one radio sends out a sounding signal on all channels in the channel group. The receiving radio develops the LQA score but does not send a responding signal. It is one-way transmission. Exchange is when a radio transmits a signal and the receiving radios return a signal. Both stations develop a link quality analysis score, and it is a two-way transmission. So the way Sergeant McCusker likes to say this one is, I'm trying to, how do you walk into this one? It'd be like if,
It's like you're having a conversation with somebody, or even on Discord here, and we ask you guys a question, and it's like going like, "Sup," and then you get no response, just nothing.
yeah. So that's
You're
the
ghosted.
sounding. But
That's what
if
the
an
kids say.
exchange is if I were like, hey, Sergeant McCusker, sup?
Yo, what's up? How you doing?
See, now we're having that two-way transmission. We're both talking. So does that make sense? Everybody got that?
Yes, sir.
You got sup and silence, and then you got a sup and sup.
Everybody get it?
Yes, sir.
Sir.
This does not work. Let's just keep going.
All right.
AME.
There are other different types of modulation waveforms that this radio is capable of. AME is one of them. That is when the suppressed carrier with only upper sideband. So if you remember when we talked about single sideband, you can jump back and forth between upper and lower sidebands. With AME, the carrier is suppressed and you only get the upper sideband. Barbara, what you got? I see you typing. Or are you still typing? Are those notes for you?
He could be typing for himself, and then his Discord's just open. Sometimes that happens.
Okay.
No, I was typing a question, but I didn't want to interrupt the.
You
train
can
of thought.
interrupt.
Yeah.
Oh,
It's fine.
well, the the radio signals like between sounding and exchange, it reminded me of like a show I watched, Lost.
Oh god.
There was a radio frequency in that show, like that
Sure.
they couldn't respond to. Like, would that be what sounding is? Like, it's a radio frequency you are unable to respond to, or is it something that you just don't respond to?
I've not seen the show.
It's more
to
like you're just not looking for a response. You're just sending out a thing to let the other people know you're there. It's like a beacon on a satellite almost, where it's just notifying you that like, hey, this is me. I'm here, but I don't expect anything back.
But you are able to receive something back.
Not necessarily. Not with that mode. Because you're not even looking for something back, so it's not even a capability. It would be called an exchange if you were getting something back.
Okay.
Yeah,
Thank you.
what you're talking about is kind of like if they programmed a radio for receive only, which is an option you can do with that program I was showing y'all. And with the radio, you can set it up so that it's only in receive, and you can't transmit back as much as you want to. Like, it doesn't matter, even if you had a handset on there, it won't let you if that's programmed in there. All you can do is listen.
Yes, sir.
I think that's more kind of what you're talking about. Also, Lost is a terrible show, but that's completely unrelated. All right. Amy, keep going.
All right. So AME allows conversations on citizen band, commercial band. Another form. Do you have something? Sorry, McCusker.
Well, yeah, kind of. So with AME, it's only an upper sideband for starters, and then the carrier is that carrier that was suppressed before. It's important to note here that what you're doing is reinserting a little bit of that into the signal again, so that AME can actually work. So you can talk to those AM radios that normally you wouldn't be able to talk to. That's all.
All right.
You're good. CW.
Radio mode of CW, that is continuous wave. You can use it for Morse code. It is a stable 1 kilohertz tone, and they used it for tapping out. What era was the tap out?
Vietnam.
Vietnam? Back in Nam?
Back in Nam.
They could use this to tap out. So if I tapped once, and then I tapped again, what letter of the alphabet did I just tap?
I know.
What you got?
A.
A, absolutely. If I tap twice and then tap 3 times. What letter do I have?
Boy, that's a hard one.
Would that be M, sir?
That would be Mike. Perfect. Any questions on CW?
No, sir.
All right, so radio is also capable of FM. It is used with a line of sight versus beyond line of sight of HF. We use it specifically to talk to sister services, aircraft, and you guys will be going into FM mode when we do part of our PMIs. So day 2,
Yeah, day 2.
3, sorry, day 2 in class, total day 3. You'll be, oh, well, I guess you do program some FM tomorrow. So we're doing it in our labs. Just leave it at that.
Oh boy.
So this is all of the stuff that comes with the radio. When you purchase this from Harris, this is what you should be, emphasizing on the should, be receiving. You can find this in Figure 2-1 in the operations manual. So it's going to be coming with a whip antenna. That's also the OE505. This antenna can be, it's that full band. So you remember how we talked about you wanted that wideband radio or antenna that could talk in the the HF and the VHF. So that way you can hit the full range of this radio. That's what this antenna will do. Comes with a base adapter, an antenna bag, antenna base, collapsible whip antenna, and a NIVIS, which is a near vertical incident HF only. Okay, so the NIVIS is only for your HF. You can see that because it is 3.5 to 30 megahertz.
Yeah, make sure you guys know that. And the NIVIS isn't like an antenna itself, it's a type of antenna. It's not like an actual antenna, like OE505 is an actual antenna.
You want us to know the range?
It would be good to know this range.
And it is also in your Figure 2-1.
But it's also in your TO.
Yeah, so if you memorize it, that's great, but you can find it. So
Gee whiz sort of thing.
Yeah, just gee whiz. Continuing on with what comes with this radio when you purchase, you get a handset. That's looks like a telephone with a push to talk button. It comes with a backpack. It's a little green bag.
Backpack.
That's CW key. And you can use that for Morse code or like we did with the tapping out. Comes with a ground state kit for clear reception, a 6-foot extension cable that allows you to take off the KDU on the front of the radio, and then you have 6 feet away from that you can use it. It has a... Sir Erwin, did you have something?
No, I'm just...
Hi, Ms. Erwin.
Hello.
All right. It also has a Y adapter assembly, and that adapts the CW key and handset.
So I'm guessing, what's this thing? What happens if this isn't included?
If that is not included, I like to say you're going to have a bad time, because that is the radio itself. That's the most expensive portion of what you have purchased. And if you don't have a radio, it's not going to do you any good to have a battery box operation manager, manual, tag chat, or the programming, because you don't have the meat and potatoes, I guess.
Exactly.
And so all that other stuff I just read off and said that would do you no good is also included and supplied when you purchase. The only thing I did not mention was the HF RPA. That is the radio programming application. And this
CPA
allows
now.
you to CPA now. It allows you to program it from an external computer. Easier for, it's faster, easier, greater, all that. And that's what Sergeant McCusker showed you guys earlier.
Yeah, that was CPA I showed you guys earlier, and we'll go more in depth into that tomorrow when I teach you guys.
We've got 3 ways to configure this. You've got a man pack, so that's when you put on the man pack backpack, that green bag we talked about, and you can walk around with it. You've got vehicular, where you install it into the base, the console of your vehicle. Probably not your Prius, but if you've got
don't put it in a Prius.
Yeah, don't do that. And then you've got a base station, and we do have one of those in class, and I will show you tomorrow. But it just allows you to hook it up to external power amplifiers to give you some further distance. You're going to typically see this in like, would you say BDOC? I know
Yeah,
you say
BDOC
command
is where
post.
I see it.
Yeah, so you guys would find this in like your command post.
Yeah, BDOC,
Uh,
command post. LRS typically has one, like vehicles. They'll have one. Because they're talking to like flight line, or they may be talking to their plows.
all right. The diagram is a depiction of how the man pack would work. You use a whip antenna and your rechargeable batteries, and then you can just walk around in the field. There's the vehicular, with it you want to use your whip antenna, and it's usually mounted in the center console of the vehicle. That is a
You're
Hummer, not a
mounting
Prius.
the whip antenna in the center console of your vehicle
Sorry,
for the
you
vehicle.
want to, not the antenna, you want to probably put that antenna on the outside of the
Yeah,
vehicle.
yeah. So I'm
Uh,
guessing these
A
things.
radio is mounted on the center console of the vehicle.
You got this.
And our last configuration is the base station, which I said you guys will see in class. The mission will dictate the type of antenna. You have a high power amp, and it is used for operation centers or command post. So we talked about the radio wave characteristics, the propagation characteristics. We talked about single sidebands and its advantages. We talked about peak envelope power. We've also discussed the specifications of the PRIC 150. We talked about ALE and the different types of it. We talked about 3G, 3G plus, sounding and exchange. What are sounding and exchange?
Sup.
Sup.
Boom.
That's exchange. And then if I just ignored you, we're sounding. This radio has multiple other modulation waveforms such as AME, CW, and FM. We talked about the typical equipment and the configurations that it is in, and that's it.